Chapter 2, Exercise 25. Is A union the union of B always the same as the union of the set A union X such that X is in B? If not, then under what conditions does equality hold? Note that I'm saying just B instead of script B. Thankfully, there's not like 1,000 B's as there was A's in the last exercise, so we can just stick to calling um, this symbol B and not script B, and I will try to keep it that way for the rest of the video because it's less confusing. Right. So I think that, in these types of questions where there's no real guidance on whether they're equal or not, then what I try to do is just make some progress, put some motion forward, whichever way possible. Either try to prove that it is the case or try to come up with a counterexample. For me personally, I think it's a lot easier to try to prove that it is and then try to see where the proof fails if that's the case, or if it doesn't, then just arrive at the fact that these two sets indeed are the same. So, in that spirit, I will do that. I encourage you to try out your own method, whatever feels best for you, but this is what I'm going to do. So, the question is A union the union of B equal to the set A union X such that X is in B? And I actually like putting the question mark here. To do that, let's just decompose the proof as usual into showing inclusion of one set in the other, or rather, not inclusion, but subsets. Show that they're subsets of each other. So we're going to show that A union B is a subset of A union X such that X is in B. Well, potentially, because we're not sure. So to do that, as usual, let's suppose this time around, since there's an X here, here, I'm gonna use S instead. Suppose, and I'm gonna call this set, I'm gonna call it T. So let's just define T is gonna be the set A union X such that X is in B. Because rewriting that set every single time is painful. So let's just suppose A is in union of union B. Then by definition, S is going to be either in A or it's going to be in the union of B. So we're just going to take this, I don't know if branch point is the right way to call it. Um, that's what a very specific thing is called in complex analysis. And I don't know if it's a branch point. I like calling it branch point because the proof kind of branches out into these two cases where you have to show that this is true and this is true, or rather, they're both true separately and in tandem. But anywho, we're going to take the left branch here and consider that S is an A. Oh, I forgot. Or both. Can't forget. But as usual, you'll find that if we show that this is true and this is true, then this case where both are true is pretty trivial in the loosest sense of that word. Okay, so if S is an A, then and note one thing, I'm gonna consider that this A and this A are the same. Because if they're not, and this is just like a random symbol on a different scope, then the whole proof falls apart. But if we consider that this A is the same as this A, then I think everything's good. I feel like that's a fair assumption to make. If it isn't, then Anderton's a horrible author of math textbooks, and I kind of don't want to believe that since I am doing the whole thing, or I'm going to record videos for every single one of these exercises. So I will live in blissful ignorance and assume that this A is the same as this A. With that said, if S is an A, then there exists some A union X in T, such that, S is in A union X. Because, well, S is an A, so it has to be an A with the union of anything. right? Therefore, S is in the union of T, which is the same as saying that S is in, or rather, I'm going to expand it now, A union X such that X is in B. And maybe I missed this annotation. For any X and B. Hopefully that. At this point, we've developed some maturity with set theory to just know that you can just, if you know that S is an A, then S is an A union whatever. Whatever exactly any set you want. Any set you can possibly think of. Okay, so S is in the union of T, meaning that S is in the union of A union X, such that X is in B. Cool. Now we're going to take the second branch. If S is in the union of B instead, then there exists some X in B such that S is in X. Cool. Now what this means is that then there exists some, or rather, then S is in A union X for some X in B. So there exists some A union X in T such that S is in A union X. Therefore, S is in the union of T. So, yeah, pretty much the same proof as above. We just find that if S is in union of B, then it must be in some X. Therefore, it must be in A union that X, this X that we talked about. And if it is in that X, then there exists one of these sets in T such that S is in A union X. I'm just pretty much just reiterating all that I've said. Sometimes I feel, for me, that personally, my opinion, that it's good to just double check through your proof, read through it again, see if it makes sense to you. That's how I usually catch mistakes. I try to keep these videos as unedited, unfiltered as possible, just so maybe you fell into one of the same mistakes I did. I mean, I do solve these at least once before I record these videos. I normally have the solution open right next to me, but I try to do it on my own and just use the guides, the solutions I've written up as a guidance to the side, just so that it is much more resembling me solving the problem. Well, it kind of is. It is me solving the problem, and such that you can actually see my thinking patterns, how I approach these sorts of exercises on the go, and it's not just some like scripted, premeditated thing. I feel like I make this video every other video. I make this point every other video, but who knows? Maybe this is the first video you're watching, and yeah, just a preview of what many of my videos will look like. I'll just make a bunch of mistakes, but eventually I will get to the right answer because I have usually gotten the right answer previously, and I have it there for reference. So yeah, don't despair. We will get there eventually. Okay, with that said, if S is in the union of T, then S is in the union of this set. Let's just spell it out all the way through. Right, and then if S is in A and S is in the union of B, then S is in the union of T, which can be seen, I'm going to say, the nastiest pair of words in mathematics, by inspection. I hope it's clear, just to make this point a little bit more clear, just because I don't want to write. That's the main reason I'm not doing it. But if if S is in A and it's in the union of B, then both of these apply. This applies, this argument applies, and this argument applies. So if both apply at the same time, we definitely have S being in the union of T. Anywho, all this to say that A union, the union of B, is a subset of the union of A union X such that X is in B. Okay, so we've done one side of the subset relation, the equality proof, I mean, and now we have to show the reverse is also true, or it isn't, and if it isn't, then we have to find the conditions under which equality holds. If you watched the last video, then you probably know that is my least favorite type of question. I hate it. I despise it. Because I feel like that kind of proof where you're just like supposed to come up with some general rule for which these random, arbitrary, almost nonsensical sets are equal just seems a little out of left field. I don't see the point in it. But then again, what is the point to doing set theory in your spare time, right? So, anywho, moving on to the proof. Let's suppose S is in the union of T, right? As usual. Then S is going to be in A union X for some X in B. Or rather, if we want to be super pedantic about it, then there exists some A union X in T such that S is in A union X. So now we can actually spell it out. So there exists some X in B such that S is in A union X. Right. So again, this proof decomposes into two branch points. The first one is if S is in A, rather, I'll just spell it out. Since S is in A union X, then S is in A or S is in X or both. Okay, now if S is in A, then automatically we have that S is in A union the union of B. So that's a pretty simple branch that we can get out of the way real quick. And then now if S is in X, then there exists some X in B such that S is in X. Haha, it spells sex. I hadn't noticed that until now. So S is in the union of B, and because this is the membership requirement for being in the union of B. And then, oh right, meaning that S has to be in A union, the union of B. And then if S is in A and S is in X, then clearly S is in A union of B, whatever way you want to flip it. So the union of A union X such that X is in B is a subset of A union the union of B. Thus, we conclude that A union the union of B is equal to the union of A union X such that X is in B. And there we go. There you have it. Thankfully, these two sets are indeed equal. I I don't see where I could have gone wrong, honestly. It seems a little suspicious that Enderton would pose this question this way and then um have the sets not be equal, but um I don't see where I could have had a flaw in my reasoning. It sounds wait, um okay, wait. I feel like I missed something. Um oh no, I didn't. Okay. Yeah, so I was guessing that one of these two wasn't gonna hold, um, but I feel like I was pretty rigorous in proving it. Though if you do see where I made a mistake, please point it out in the comments. I would really appreciate it. I'm trying to compile as many resources on math, trying to make math easier a little bit by posting for people by posting these videos, and I would hate to have these videos be wrong. Um, I'm okay with them being bad. I just don't want them to be wrong. Um, right. There's that. Also, I have been thinking, and people on YouTube are always kind of obsessed about the like dislike ratio. Um, because it is some sort of validation, right? I mean, it's fair. It's social approval by the people watching your videos. I I think that's cool and all, but I'm not doing this, thankfully, as a like I don't live off YouTube. I'm not making any money off this, at least not currently at the time of filming this video. Um, and I honestly don't care about the like dislike ratio in terms of like assigning self-worth, but I do like the idea of having feedback on these videos. So if you genuinely don't like the video, if you think it's confusing, if you think I should do a better job, like if you have nitpicks, please like leave them in the comments instead. But if you think like genuinely I should redo the video, then please leave a dislike. If you think it's good, or if you think it's good, if you think it's fine, then just like either like the video or don't do anything at all. If you want to write a nice comment, that's always good. If you want to nitpick something like very tiny, maybe like a minor errata, I guess you could call it, then leave it out in the comments. I can maybe pin it. But if you think that a video is so confusing to the point where it needs re-recording, or to the point where it's distracting, then please dislike it. And gauging on the amount of dislikes I get, I might re-record it. Um, I probably will. I've been considering heavily re-recording exercise 24 just because it was a rare occasion where I hadn't fully worked out the proof of it, and I kind of just like did it on the fly. It was for a very minor part of the video, but still, it's just something that's been weighing on my mind a little bit because I don't know. I have this split. By the way, this is just me ranting. The video's over. Like the proof is done for at this point. You don't have to keep watching if you don't want to. Um, but right, I started these videos just as a way to keep me accountable for actually getting through the set theory book. Also, as a way to have some sort of repository of answers, because sometimes I'll just write them in my notebook and then lose the notebook, or I'll just throw the notebooks away. And I kind of wanted some persistence, some permanence to the work that I do. It's also nice to look back on the videos that have been uploaded and the growing playlist and see that I've actually, put myself through over 30 exercises of set theory at this point. It's nice to see progress in that way. Highly recommend it, by the way. If you want to start um, doing these videos alongside me, if you want to record your own videos, then let me know and, we can collab maybe. I don't know. Is it collab or collab? Anyway, um, uh, yeah. So, yeah, I These started out as a personal thing where I would just like have the answers and an explanation readily available to me in case I ever needed it for reference. Though I do obviously have a public aspect to it, otherwise I would have just made these videos private. That's because I believe that someone, maybe, who's working through these problems might be able to um, benefit from it in some way, shape, or form. And I don't think that gatekeeping my answers is the right approach to this. So I'd rather just make them public. And while I still don't do it for public approval, I do take pride in my work to some extent, and I would like these videos to be of an at least an acceptable quality, which is why I'm asking you if you really, 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 or rather, if you even somewhat think that the video should be re-recorded because it was confusing to you, then leave a dislike. And if I get a non-trivial amount of dislikes, then I will re-record the video and upload it. I'll keep the original always. Like I don't believe in deleting videos unless I did something really stupid, and it's affecting people negatively. But I I am open to re-recording these videos and just like fixing the mistakes, making them cleaner, um, and maybe just like giving better explanations. But yeah, I might make this announcement. This is my first time doing it. I'm clearly winging it. In future videos, I mean, nobody watches my videos at this point, but if you ever stumble upon this and you want to leave a dislike, then please do so. It's helpful feedback for me. Um, and yeah, that is all for this video. As usual, I hope it was helpful. I will see you in the next one. Bye bye.